LDA is the same thing as LDA, is only the difference here how to calculate B and S. So B and S, the formula is here, it's written, M minus this, K, I, and so on. And how to find, we do the same thing within the class. What we do? Minimize. Between the class, we maximize. So at the end, we have to solve something similar to this. We have to find the eigenvalue and eigenvector for S minus 1, B. Okay? Same thing. Okay? And the end, when you get W, you have to make sure that the norm is 1. So your alpha, after you find the eigenvector, you have to divide it by this coefficient to make sure that it is 1 unit vector. Okay? So this is our data. We do the projections. We call, when you have the K matrix, okay? So it will be the first columns is for the class 1, after for class 2, class 3, and so on. So we call it K index Q, okay? Q can be 1, 2, 3, until number of classes, okay? How to calculate this one here? You looking for this one. So we have the M, and the total is just the averaging, nothing else. This is the target we want to, and at the end, we have to do the same thing here. We do the derivative, and we find. So I'll not go in details. You can check it. But the most important is this slide here. Okay? How to find B, how to find S, find the eigenvalue, eigenvector for S minus 1B as we did before. You need to normalize your vector alpha. Okay? So let's take example here. This is your x1, this is your x2. You have this kernel function, which is polynomial of degree 2, or quadratic equation. This is your kernel matrix. What is the size of x1 here? 1, 2, 3, 4, 4, right? So the 4 columns are K1 for the kernel for the class 1. The last 4 are for the kernel for class 2. So we call it K1 and K2. Okay? So how to find M1? M1 is the mean of this matrix. M2 is the mean of this matrix. What we do the mean here? We keep the size n, just add 4, you divide it by 4, right? The mean here, add those 4, you divide it by 4, you get M1 and M2. The total mean, what you do? You add all the 8 columns, you divide it by 8, you will get your M. You see here, N, I put transpose, should be column. Just to write it nicely, I put this, put T, which mean is column, not a row. Clear? Next, what we did? We calculate the B matrix and we calculate the S matrix. We have the formula for that, just to apply it. And now what you need to do? Find the eigenvector of S minus 1 times B. This is the big matrices. Of course, we have to use a coding, okay? Okay, so at the end, this is how to do it. Okay. Let's summarize everything. So what we have here, please? We have the data, labeled data. We have the kernel matrix. What is the size of kernel matrix? The total. Total kernel matrix. N by N. Okay. If we do the kernel, K, it's still N, but the size of N1, N2, N3, up to the classes. Clear? You have to calculate the mean for the kernel here. What is it here? We take the matrix here, we multiply it by 1 to take the average, you divide it by NQ. So this is the formula. And the total, take all K, you multiply it by 1, you divide by N. Clear? Compute between.
What are the reason multiply by 1?
Because if you have, you remember when we do, look here, for example here. If you have, for example, here you have x1, x2, x3, yes? I want you to find the mean of this one, x1 plus x2 plus x3, what is it? If you multiply by 1, 1, 1, you divide by 3, it is exactly the same thing like x1 plus x2.
You have put it a value 1, not a matrix.
Sorry?
Here is K1, not a unit vector.
What?
When you put, okay, so when you see 1 in the matrix equations, mean 1, 1, 1, 1, 1, 1. Always. When you see I, it is identity matrix. When you see 1, it's always 1 row. When you see 0, means 0, 0, 0. This is agreement in the equation, okay? 1, 1, it is not 1. Because does not exist 1 in the matrix. It's only identity matrix. Clear? So, after you calculate B, you calculate S, you calculate the eigenvector for this product. When you find the alpha, you do these normalizations. Now, you have the data, you have to project it on the new, this direction alpha, it will be your beta. So what is the size of beta here, please? What is the size of beta? Beta is matrix, or row, or column. What is the size?
I think n by something greater than something.
The size is 1n. You see here, when you do the product, look at when you do the product of a vector. Look at it. You have the vector here, and you multiply it by this matrix. What is the total piece here? What is the size in this one? 1 times n. Kernel is n times n. You simplify, what will be 1 times n. So it is a row matrix. Okay? And this is the new coordinate of your Kernel LDA. Okay? And there is another technical question I just added, but it's not really in the exams, just for research. Sometimes S minus 1, we cannot find it. It is not inversible. So what we do, we add just a small number times identity matrix in order to be able to find the inverse of the matrix without changing a lot of things. That one I will not go in details of it, just idea. Okay. Consider here, for example, we have alpha, and we have here, for example, sometimes when we are not able to find the inverse matrix, look what you get. You get something with complex number, with something is not really easy to deal with. But when you add the idea here, you get clear eigenvalue and eigenvector. Because sometimes the inverse matrix does not exist. Means you are dividing by 0, or something very close to 0. So it gives very wrong numbers, okay? Just to be aware when you are doing coding about this, to be careful. Again here, okay, let's do examples here. Starting, just to put it down. Okay, consider data in this table here. We try to answer the following questions. We have data plus and minus. Okay, so according to the data table here, what is N1, what is N2, what is N?
Number 4, N4.
N is 4, excellent.
And
N1?
N 3. 3 number of features.
N1 is the size of the class, first class.
2.
Okay, how many classes do we have here, according to the table?
2 classes.
2 classes.
1 minus
They are labeled by
1 minus
1 minus. What is the size of 1?
2.
2 and 2. So N1 is 2, N2 is 2, and is okay. How many features do we have here?
2. 2. This is 4 and 2.
M, number of features.
2
only 2.
features.
Here. 4.2, sorry, 4 and 2.9.
2.9.
Yes, two features, right? Okay. Can you find the mean of each one and find SB? How we can find it? We have the mean here. So please, in table is giving the data as